Okay, so what can we do? Well, already in Haskell, we could use the maybe type to actually distinguish the cases where we can produce something and where we can produce nothing. We can do exactly the same thing in Agda. So here I've imported the maybe type from the standard library, so we can go and take a look and see what it looks like. Okay, so it's hidden in some deeper imports, but here's the definition of maybe. And it looks just like in Haskell. So we see that maybe A is a type which has one constructor called nothing, which just produces maybe A with nothing attached to it, and one constructor called just, which given an A gives you a maybe A. So the only difference compared to the Haskell definition is that here we have written the constructors with lowercase letters because we can. It looks a bit nicer, whereas we do tend to use uppercase letters for types and not for constructors. Okay, so if we use the maybe type, then we can hope to do a little bit better. So I'm going to copy this, comment out the failed attempt, and instead of producing an A, which is too much to promise because I couldn't actually do it here, I'm just going to say that maybe I will produce an A, and then let's see what happens. So I do this, I put a hole on the right hand side, and then I reload the file, Control-C, Control-L. Okay, so now we see that we have to produce a maybe A, and we can do basically the same thing we did before, right? Let's look at the list, Control-C, Control-C, pattern match on X's, and now if the list is empty, then we know that there's absolutely nothing we can do, so we're just going to return nothing. Okay, and if the list is non-empty, then we can look at the natural number again, and if it's 0, then we can return the first thing, and it's tempting to try to just return X like this, but then we see we have a type mismatch because X is an A, but we want a maybe A. So here what we want to return is just X. Okay, and in this case, again, we have a list with n+1 elements, or m+1 elements, and we want the nth one of these. So we just peel off the first one, and do a recursive call on the nth, and this time the recursive call itself will produce a maybe, so we don't need to wrap it in a just or anything like this. Okay, so this way we could actually complete the program, right? So one moral of this story is that by being a little bit more honest about what we actually can do, we can write the programs we want. So it was too much to claim that we could produce an A at any point, because in particular this list could be empty, in which case we had no A's, but we can always produce a maybe A. But one thing that's a bit disappointing with this type, of course, is that there is an alternative definition of this function. Let's call it bang bang prime, which just always returns nothing. Right. So the type itself doesn't really tell us what the function is doing. So we have to go and look up the documentation for the function, if this is in a library somewhere, in order to see what that is not doing this wrong thing, but actually doing the sensible thing and looking things up into the list that we expected. And also it's a bit annoying that every time now when we use the function, we always have to check if what we got back was a nothing or a just, right? So I mean, it was arguably even worse before, because before we didn't even know if we would get anything back in the Haskell version. We could just silently crash. But here we have to again and again check that we got the right thing. So in the next video, I'm going to show you how in Agda we can actually get something even better by being really precise about what we know and what we want. It's a bit of a cliffhanger.